Okay, so we're reviewing for your quiz, and I'm giving you some examples here of what you might see so that you can practice. Sometimes you will be given the values of the logs. They'll be given to you. That means in case you don't have a calculator, or back a couple of years back, calculators only had base 10 logs. So you could only use your calculator for base 10 logs. Nowadays, a lot of calculators are able to let you input the base, whatever base you want, and they'll calculate it. But you'll see in books sometimes where they'll give you these values for you to work with when they ask you to evaluate these logarithms, and even when you're not allowed to use a calculator. Okay, so I'm going to explain two examples. Notice it says to use these values to approximate the value of each logarithmic expression. So I've given you three values. They're all base 2 logs. And number 1 says log base 2 of 2 over 7. Automatically, first thing you do is you use your logarithmic laws, and the quotient law here states that you can, whenever you have a quotient, it is equivalent to writing it as a subtraction of logs. So you'll have log of the numerator minus log of the denominator. Okay, now what is log base 2 of 2? Log base 2 of 2 is 1. And we saw in class how this comes to be. I'm going to explain over here to the side why this is 1, just in case you don't remember. So whenever you have log base 2 of the same number, the base and your argument are the same number. This is equal, let's say I don't know what this is equal to, so since I don't know, I'm going to use x, okay? And I'm going to rewrite it as an exponential. I'm going to rewrite the log as in exponential form. So that would be take the base, raise it to the x power, and equal it to the argument. So this would be 2 to the x power equals 2. And now since the bases are equal, it must mean that the exponents are equal. So x is equal to 1 because the exponent here is 1. So x has to be equal to 1. That means that log base 2 of 2 is equal to 1. And we also saw the standard form of this property, which is log base b of b to the x is going to equal x. What this means is anytime you have the base of the log equal to the argument, then that whole thing will be equal to the x, to the exponent of the argument. So in this case, since the exponent of this argument is 1, then this will be equal to 1, like we just demonstrated. If the exponent was a 2, then this would be equal to 2. And that's why this property works here, okay? So I have log base 2 of 2, that equals 1 because the exponent is 1. This would be 1 minus log base 2 of 7, which they tell me what that is. It's 2.8074. And that equals, you can take your calculator and calculate 1 minus 2.80, and it's going to be negative 1.8074, and we write approximately, because this decimal expansion is larger. Okay, so there's your answer for that one. For this one, log base 2 of 28. Well, 28, I don't have log base 2 of 28 as a given value in the information they gave me, so I'm going to have to break up 28 into two factors that I can use. I have log base 7. 7 is a factor of 28. And I don't have 4, but I know 4 I can break up into 2, and since it's base 2, I can probably work with that. Let's rewrite this first. This will equal log base 2 of 7 times 4, right? That's 28. And whenever we have a product as the argument, I can go ahead and write this as an addition of logs. Log base 2 of 7 plus log base 2 of 4. And now I know what log base 2 of 7 is because they tell me. So this is approximately equal to, log base 2 of 7 is 2.8074 plus log base 2 of 4. Now, how much is log base 2 of 4? There are two ways you can figure this out. Notice they didn't tell me up here what log base 2 of 4 is, but I can figure it out. I'm going to go off to the side here and explain this part to you. I can do two things. Log base 2 of 4. This is as simple as saying 2 raised to what power is equal to 4. And automatically you know 2 to the second power is 4, so this has to equal 2 because 2 raised to the second power is equal to 4, and that's how you get 2. Okay? Another thing you can do is you can break log base 2 of 4 into log base 2 of 2 times 2. And this you can turn into log base 2 of 2 plus log base 2 of 2. And that is equal to 1 plus 1 because log base 2 of 2 is 1 and log base 2 of 2 of 1, and this is equal to 2. So any of the two ways you will get a 2. So this is plus 2. And that will be approximately equal to 4.8074. There you have it. And that's how you use these values when they're given to you to evaluate log expressions. I will see you in my next video with another example using, we're going to write logarithmic expressions as a single logarithm. Okay? I'll see you in the next video.